guess I kind of am dating myself with this as well. I don't know how many people remember this commercial. You know, it's 10 p.m. Do you know where your children are? And it was kind of, you know, right at the dawn of sort of helicopter parenting, right? And while it might not be a great thing to be completely invasive in your children's lives, I think when you're talking about infrastructure, you know, it's a different story. You should know every little detail. So, I really wanted to do a live demo in this talk, and I kind of borked my code. I changed, I've been using Python behave for my testing framework, and I switched over to PiTest, and the syntax was just a little bit too different for me to figure out, like, and get everything working last night. So apologies. We'll just play it by ear here. Quick disclaimer, I've been thinking about this stuff for a while, and I've given a couple of talks on this subject, but I'm not actually using any of this in prod. I think this is definitely, like, testing states, testing all the things that we build with Salt, I think is definitely something we need to get better at. I think it's really where Chef excels, I feel, is in their test-driven stuff. And I think that Salt needs to kind of up the game a bit on that. And I think people are aware of that. But I guess I mean that as a call to action. If anybody can write the code that people need to, like, do any of these segments of testing that I'll talk about in this talk, like, it's very much needed. So this is me. I'm Jason Denning. I work for Cloudera. I work on the certification team there, which is like the certifications we give out. You know, you take a class, take the test, get a cert. Cloudera is great. I highly recommend it. If anybody is looking, feel free to come talk to me. I would love to get a referral bonus from anybody who starts working at Cloudera. We're doing really interesting work on the cert team. The stuff that I'm using Salt for is spinning up, well, we've recently moved to a performance-based exam for all of our certification exams. So that means it's kind of like the Red Hat exam, where we give you an actual Hadoop cluster, and you've got to perform tasks on it, and that's how we evaluate if you know what you're doing. So it's really interesting in that I'm developing infrastructure to spin up, like, not hundreds at the same time, but tens of clusters of Hadoop clusters with various configurations, various node settings, various problems embedded in the clusters for people to fix. So it's really interesting work. Salt makes it a lot easier. See, that's my GitHub and my Twitter. I really want to get better at doing Twitter. I don't use it very much, so I highly encourage people to, like, ask me stuff on Twitter. I will respond. I'll respond a lot more likely than I would if you emailed me. Okay, so here's the basic argument. DevOps says that infrastructure is code, and I believe this is true, right? As we move to more infrastructure as a service type stuff, you know, cloud environments, the definition of your infrastructure really becomes this code that you write. Code should be tested. All code should be tested. So therefore, our infrastructure should be tested. There are lots of other side benefits you're going to get. If you write good tests, you're going to have some good documentation built in. It's going to really improve your workflow if you have some good automated tests, just because you'll catch these quick errors earlier in your development process. It's easier to find stuff. It really helps with bringing other team members in. If you have a nice test suite, you know, if you have somebody that you maybe wouldn't want, like, making direct changes to your infrastructure, but you do want them to try to contribute some stuff, then you know, having tests is really key to that, and having an automated continuous integration framework. Yeah, this is something I really want to talk about. Did anybody catch this article last year? The Oring Theory of DevOps. It was about 6-8 months ago, I think, when he published it. Anyways, check it out. Get this link. I'll have these slides up, you know, this weekend, but check this article out. It's great. So what this guy is talking about, he's kind of analyzing the results of the 2015 State of DevOps survey, all right, which I think Chef does, I'm not sure. So this survey showed these massive gaps between top performers and everyone else, essentially. Kind of noted some here, 200x better lead times, 60x fewer deployment failures, and 168 times faster mean time to recovery from errors. That's huge. I mean, 2 orders of magnitude. And so this guy was trying to figure out what's the difference. What are these guys doing different? Because everybody's kind of doing the same general thing, but there's some differences in the process. And what he started looking into is this economic paper, the Oring Theory of Economic Development. And this paper was inspired by the analysis of the Challenger shuttle explosion, right? And the Challenger shuttle exploded basically because of one failed O-ring. And so this economist started writing a theory about general work output. His thing's kind of related to wages and productivity. And this guy related to DevOps makes this point that when you have a process that has lots of individual tasks, right, that are necessary to complete the entire process, then small differences in the quality of how you perform those individual tasks. So say your error rate. If you blow your deploy, 10% of the time, then you have like, 0.9 quality out of 1, right? The thing is, as you sum up all these tasks, and there's some math on this. The guy's article goes into it in much more depth. But when you start modeling this out, you see these huge, huge performance hits from just like really minuscule errors in these smaller tasks. So it leads to the conclusion that if you have a single error-prone task in your process, it's really going to hurt you. So like, I don't know how many people, anybody ever worked at a shop where deploying code was like an event, like it was somebody's job for like half a day? You have to sit there with, yeah. No, I've had one where I have like 10 pages of like checklist items you have to go through manually, and it's like, oh, look at this and make sure there's no errors. And the thing is, if you fuck up any one of those things, like you've blown the deploy, and you've wasted all this time. And maybe you're not even sure if you screwed something up until it's too late, right? The other really interesting thing about this is that if you're doing almost everything perfect, but you've got a few little hitch points, a few little rough spots in it, fixing those weaknesses will dramatically improve your overall quality. If you're kind of, if you're working in a shit show and everything sucks anyways, then like these small incremental things don't really add up as fast. You should probably like look at the bigger picture stuff first. But if you're actually doing things well, then these little points that irritate you, really need to be fixed. So I encourage everybody to check out this article, send it to your managers. It's a great justification for why you need to spend work cycles working on this type of stuff. Hey, this is my guru summary. Never make mistakes, always come correct. That's kind of the point, right? That's what we're trying to do. We're aiming for perfection in our process. Okay, is anybody like completely unfamiliar with test-driven development? Okay, good. So this is just a quick overview, just so we have the terminology on the same page. Basically, unit tests are testing a single unit of code. Integration tests are testing the interactions between units. And acceptance tests test that the code does the thing that we want it to do, the sort of end-to-end testing. We start thinking about infrastructure, things get a little murky. Right? Like when you're talking about straight software development, this is really easy to compartmentalize. You can say a unit test is a function, an integration test is anything where more than one function or class interact, and the acceptance tests are like the smoke tests and the actual stuff you're trying to look at. When you're talking about infrastructure, I think unit tests are really hard to write. Integration tests get a little bit easier, depending on how you do it, and acceptance tests are probably the easiest. Like the existing infrastructure testing frameworks, like BATS, stuff like that, that's what they're really looking at is, you know, I expect port 22 to be open. Is it open? You know, that would be an acceptance test. They're not really looking at the details of how we got there. Actually, let me pause on this. So the way that I like to test infrastructure, where am I? Like I said, I totally borked my code base for this, so don't judge me. So I find that behavioral-driven testing really works well for infrastructure. Behavioral-driven development was kind of, oh, that's really small, huh? Was kind of pitched as this idea that, well, you know what, I'll just whiteboard this. I got a whiteboard. It was originally pitched as this idea that you could have like business users write feature specifications, right, in plain English. And then you'd hand that off to developers, and they would go write the code that fulfills these, well, behavioral descriptions. So this, well, actually, I will just use this. Hold on, let me just get my font bigger. Is that reasonably legible? Everybody see it? Okay. So the way behavioral-driven development works is you write these scenario files in plain English. And this is kind of a crappy one. There's really only a few keywords. So the feature and scenarios keywords are really about scoping. You know, you'll have, the feature is kind of the whole file, and then scenarios are things that relate to the feature. And again, I apologize. I really wanted to have some better stuff. And the other keywords that you have are given, when, and then. Okay? So given is like a setup function. When is like the condition that you're looking at, and then is the result you want. And the idea is that you write like Python functions that map to these actual text descriptions, right? And again, this code does not work, so don't take it down or anything. But you can see here that in Python, and every Python BDD library that I've seen has this commonality that they use decorators, you know, because decorators are great in Python, to kind of identify which function matches to which text strings. And there's always some sort of functionality, so you can get some parameters out of it. And basically, when you run your test runner, it'll look at your feature file and run through all of the, you know, the keyword-defined things. So when you say, given I, you know, have applied this state, then it will look for the function that's decorated with a given, that's, you know, has the text associated with it, I have applied the state, or whatever. And then it runs the when to verify, you know, various conditionals, set up like parameters. And then is where you typically do your assertions. So this is a really sweet way to do infrastructure testing, in my opinion. You get really good documentation. You know, helpful for when you have to look back at stuff, when you have to onboard new team members. I feel like it's easy to sink your teeth into. Like, I've always had this problem with TDD in general, like isolating what you're going to test, right? Like, where are you defining your units? Where are you defining your integrations? When you're doing behavioral-driven testing, you're really just writing out these little paragraphs of what you want, and then you go back in and fill out the code, right? So, you know, since we're talking Salt, we can have things like the SLS should render correctly. And then we write a function that verifies if the SLS we care about rendered correctly. And again, this is crap code. Don't go by the code. Okay, so with that brief interlude into BDD. So we have some sort of minimal testing already. I bet everybody in the room has ran this command at one point or another, right? You just tag on the test equals true to the end of your state.highState. Of course, this is better than just running highState without testing anything, right? But it's manual, it's slow, there's zero isolation when you're talking highState. You have all of this crap scroll by. Yeah, you get the summary at the end, but you might miss something, right? This is a first easy improvement that you can do. Is instead of testing at the highState level, you can also use this test keyword argument on the state.sls function, which will test an individual SLS file. So that's, you know, that's an improvement, but we're still, it's basically just in terms of isolation, but still missing a lot of the other features that we want. Jeez, this is a mess. So there are a couple of key areas that I think when you're talking Salt, everybody kind of has the same problems. SLS rendering. State logic. Or syntax. That's another one people screw up commonly, myself included. And then let's call it, you know, orchestration and dependencies, right? You might get your dependency chain wrong. Dependencies. So these are kind of the three areas that I look at for wanting to test. SLS rendering, which is unfortunately the set, like, I mean, on the classes on Tuesday, there were like 3 people around me running the lab code who had Jinja errors that were just really hard to track down. And they're sitting there digging through this stuff, trying to find the one space too many or the, you know, semicolon instead of a colon. And unfortunately, I feel like Salt's error messages in this regard are not the best. So this is why it's hard to, you know, track stuff down. If you get a render error, it just kind of doesn't work. It doesn't really tell you what's wrong. I've advocated before for people to write like a general linting tool, but it's a really hard task if you think about it, because Salt has all these different renderers. You know, you could use Mako, you could use Jinja, blah, blah, blah. Somebody could have some custom one. So my solution to this is to just use Salt to go ahead and render it. And I'm not saying that you should just you know, run it and see if it works. But there's this great function that I bet a lot of you don't know about that's state.showSLS. And what this does is it will compile your template, your SLS file, do all the rendering and everything, and then it'll actually make you know, this, I don't know if it's probably high data, low data? Makes a data chunk, anyways. So it's actually, it's the thing that Salt actually understands, right? And for whatever reason, it has way better error messages when things don't work right. The top one, this is both, they're both running on the same state, which is broken. And you can see this top one, it's got the same error message. SLS foo does not render to a dictionary, and we see that again here. But we get this extra line, the type foo.text and file.manage is not formatted as a dictionary. So that just really dialed it in, right? Like, unfortunately, I don't actually have this state handy. This is something I did a while ago. So I can't show it to you, but you can imagine it'd be really easy to dig into that problem, right? If you have a lot of state files, you know exactly what file it is. You're going to be able to find the ID really easily. You can find the state module that's trying to run. And then you look at that and say, oh yeah, hey, it's not a dictionary. So it's a lot faster. You know, it still is far from perfect. This is where I would really love it if somebody would just fix this. You know, if somebody made it so that the SLS renderer had a linting function, or if, you know, took on the gargantuan task of getting the error messages a little better and a little more directed, I think it would save the world a lot of time. So this is what that same state looks like via show SLS after I fixed the error. Yeah, so actually we can kind of see what the state was, right? So this is that data chunk I was talking about. This is what Salt actually does its work with. So this is also an interesting place to test. I've not done a lot of it yet, but like, I think, yeah, okay. So this is the same thing, essentially. Oops. But I changed the outputter to JSON, right? So then you get this nice JSON object. And you could really do a lot of cool testing once you have that sort of data structure. Like this is representing everything contained in an SLS file. And it's really highly structured. I mean, this is what Salt uses to go out and do the work, right? So you could look for things like, is my context filled in right? You know, is my source file right? Am I meeting my, if you had some sort of naming guidelines, does this match my naming guidelines? So this is one I think is ripe for innovation. Doing some sort of analytics on these state chunks. And they call them something like that, I don't know. So moving on a bit, this is getting more towards the state logic and syntax. We really want to make sure that we're testing everything in isolation, that we know exactly what we're testing, that it's not going to have a bunch of side effects that we're unaware of. Otherwise, the testing is really pretty useless. So the key is to use a testing framework, basically. I've previously used Python Behave. I like it a lot. I'm trying to switch over to PyTest with the BDD plugin, just because I'd rather use PyTest for unit testing and other stuff. And it's got some cool features like fixtures and stuff. But both work, you know, do it either way, whatever you like. One of the best ways, in my opinion, to get a fully isolated test infrastructure is to build a new infrastructure every time. So, you know, when we start talking about that, we're obviously not talking about racking machines, right? We're talking VMs and containers. So this is basically what I've been experimenting with, is one level of testing that happens at a Docker container, and then another level that happens at full VMs. I've kind of laid out the pros and cons. I assume everybody's fairly aware that Docker is much faster to spin up a container than, you know, even the fastest cloud or hypervisor is going to get you a full VM. But Docker will bite you for things like services, like cron jobs. You know, most Docker containers aren't built with this type of stuff. So you could use a really fat Docker image, but I still think you're running the risk that, you know, if you're testing states that you're intending to apply to a VM or something with, you know, a more full Linux environment rather than just a container, Docker could give you some problems if you're relying on that. It'll give you some false positives, maybe give you some false negatives. So you kind of got to do both. So don't need that. Well, let's look at a Docker file. So what I like to do, so I like to, and this is how I do Docker kind of anyways, actually. It's probably not the officially sanctioned way to use Docker, but I don't care. Basically, I install Salt in masterless mode, because I find you don't want to be dealing with a bunch of networking and PKI and crap like that when you're just building images. So basically, all this stuff is just installing Salt. I have a couple extra lines to do add some testing stuff in here. And then I'll generally just set the command to do salt call state.highstate. Again, I was kind of experimenting with some stuff here, that's why it's a little bit weird. But really, you just install the minion, run salt call with the local flag, or you can set the local file source in the config, and then run your high state. And this is absolutely a great way to build container images, by the way. Like, especially if you're working with VMs and containers, you can have one source of all of your infrastructure code and use it everywhere. I hate when Docker files get too long with, even you can tell just looking at this. This chunk of commands is the hardest part in this whole file to read, right? And really, the ones I do in production are like much shorter than this. It's just installing salt, running high state. You tend to want to mount your states and pillar as a volume, just so that makes it really easy to change, right? Oh, this is not a slide. And then what I like to do is use Packer to build my other images. So I'm using the same states. I'm using the salt provisioner on it, and everything is really nice and in sync. So the next big thing here, we've got all the pieces, right, to look at these things I've been talking about. But we need to automate the whole thing. And this is the part I really wanted to demo today. My plan was to build a little CI infrastructure using the reactor, and it just didn't work out. But the thing you need to kind of pay attention to is there's sort of two layers of the testing. Since you're going to want to be spinning up lots of individual Docker containers, maybe lots of VMs. So you need this outer test runner that's handling all that sort of stuff, right? And I really want to use Salt for that. The Docker ng module is really good. I hit some rough edges with it. Like, it seemed like the logging wasn't working right. I don't know if I stumbled onto a bug or if it's fixed in the next version. But that's kind of my plan. I'm going to move to be doing all of this, sort of orchestration level stuff in Salt entirely. And so Salt will, build the Docker image. It will start the Docker image, and it will instruct the Docker image to run its tests, and then collect everything together and give you a good report. The other side of it is you need this inner loop, right? Because you want the tests to actually run on the infrastructure. So you kind of need to have your test runner in the container, right? And that's why, if we go back to this, that's why I'm installing PiTest BDD. And I was basically, what I was doing here, what I was trying to do is change this around. So the Docker container, again, because I was having problems with Salt's control of the Docker containers, I was basically having it so I could start a container, and then I was going to be using Docker exec to actually run the test runner, which is just pi.test. And then have the outer layer kind of collect everything together in one big report. It's a problematic thing, really. It's one of the rough patches for me, is getting all of the individual reports together in one cohesive thing that you can look at. Yeah, and again, I really want to do a live demo. It's not going to happen. But I'm very interested in people's thoughts on this. If people have comments, those are just as welcome as questions. Yeah. And I go back and forth on that all the time. So the question is, why not use like the PyObject renderer or the straight Python renderer? In a lot of ways, I really want to, but I feel like it would hurt my team a little bit. You know, I think it'd be harder for people on my team to kind of grok the whole thing that I'm putting together. And it's one of those like, it just feels like a step backwards in a sense, you know? Like 7, 8 years ago, that's what I was doing, was writing individual, you know, Python files that would go execute infrastructure stuff. And then got to a point where I could define everything in nice, pretty YAML files with like, you know, Jinja variable interpolation and everything. And man, it just looks so much nicer and so easier to read through. So you're right, it's a lot. I mean, this is why Chef has better test integration, right? It's because when you're writing Chef stuff, you're just writing, you know, Ruby. So that's how their test frameworks work. Personal preference. If you can get away with writing PyObjects or the Python renderer, I'd say go for it. It's probably a better decision. But again, it is going to inhibit like integration with your team, depending on what your team looks like, I guess. One of the things I like about, you know, moving to these the YAML formats and having you know, a BDD style of testing where it's just plain English is that you can get people who would not necessarily be comfortable working with infrastructure to do some work. You know, maybe they can't build the whole thing from beginning to end, but they can give you a much clearer idea of what they need. You know, they can kind of scratch their own itch a little bit. My last gig, that was something, we integrated a lot of the developers into building salt states. It took a little bit of time, you know, there's a learning curve, and their stuff obviously wasn't as good as the people who do it all day long, but it really helped, you know, just having somebody else to kind of carry that weight, so. Yeah. Right. Yeah, I mean, that's really what I meant by, you know, inhibiting your team. I think most teams are comprised that way, where there's some people who are not, you know, are going to be using a different language or, you know, are just not as infrastructure oriented. Mm-hmm.
the other hand, unit tests sometimes fail, and in that case, we just need to clean up what we created.
Right. I mean, my kind of preferred workflow is to run the initial sort of linting and like rendering tests just on my laptop, before it.
Trust developers, I trust computers.
Sure. Yeah. No. Understood.
But when you're developing, you would rather run your unit tests.
Well, yeah, of course.
Before you commit.
Right. Yeah, I would run the same tests again once the code's committed.
That's what you would expect from people to do, but
So let me just map out what I was, intending to demo. So it's pretty simple. You have your SLS files in Git, right? You do a commit and push. And then here you have a hook, right? And all I have this Git hook doing is firing an event into the reactor in Salt, right? And this can do things like, trigger testing. Yeah, that's what I'm trying to do. I'm trying to move this all into Salt, right? Because really, to do this testing, all I'm trying to do is call one command line thing. So that's actually a really simple, thing to write in Salt. I keep one day when I have time, I'll, integrate this stuff a little more tightly. But yeah, because I feel like this is all very event-driven in nature, right? You have your trigger testing. This goes to your, test workers. And then you have the same thing where these test workers run their tests and then fire an event. And then, the reactor can say, okay, now integration testing. And same thing, you get an event back. Once you're satisfied with everything, then you can do your, approved PR, or, ask for verification from a human, or, actually just build infrastructure, I think, in the perfect world, right? It's a virtuous cycle. You have all these disconnected pieces that only care about the thing that they care about. These test workers only care about running tests. You could have separate testing structure. You could have your unit tests, your integration tests, your acceptance tests all be running in different frameworks if you wanted to. And then when they're happy, they just say, hey, I'm happy, or hey, I'm not. And then the reactor does sort of the hard work of saying what happens next. And especially now that we have Thorium coming up, this is going to start looking super cool because Thorium adds in all of these dependency features and kind of conditionals, which will make stuff nice. But yeah, I'm really trying to move everything to Salt because Salt can control Docker, Salt can control the cloud, right? So if I want to have Docker containers and I want to have VMs, it can do both of these things. It can control Git repos. You have all these execution modules already for free, so use them. You have PKI too. I mean, don't underestimate the value of a free PKI. Like, you can verify that the test worker that sent this event has the authority to validate an event, right? Like, that's kind of cool. So yeah, I was actually, I was attending the talk on like modular subsystems within Salt, and that's the one thing that I started thinking about is maybe it's time to start writing a testing subsystem that starts like just kind of wrapping some of this stuff and making it easier. Yeah.
How would you record what test passed and failed? For example, do it this way.
No, just with a returner.
Would you write that infrastructure out to store that in a database and report it to whatnot?
Well, again, this is part of the beauty of doing it all in Salt, right? Is if I'm just using a returner, then it's sort of agnostic of what the final data store is. Like I can have a Postgres returner or MySQL returner. I can have a syslog returner. I can have all three at the same time, right, if I so desired. Yeah, no, returners are cool. You can send the output data to arbitrary stores. It's one of the kind of big things of the Salt Enterprise stuff is they have this returner as a service, and it kind of puts all your data in an easy to view place. You know, dashboard. You can kind of drill down by job ID, see all the events that happen. It's kind of neat. Yeah. Well, so if your team like Jenkins, then I basically get rid of that, and then this is Jenkins. But so here's the thing. Jenkins is an automation tool, right, at heart. Like, it makes it easy to say, I want to run this step, and then this step, and then this step. And we've already got that with Salt. And it's, in my opinion, you know, superior in what you can do with it. So this is why, you know, plus I hate maintaining Jenkins. Java. It's actually, Jenkins servers are one of my least favorite deploys just because, like, you know, with Java, anytime you're deploying Java, you have to really, like, think about heap size and, like, all your memory issues. And then as you have everybody kind of piling onto this server, that just gets, like, worse and worse. So, I don't know. It's pointy clicky. I hate that crap. Anybody else? Well, I brought a ton of Cloudera shirts back there, like, so feel free to take 2 or 3. I like really don't want to take them home. So, there's shirts, there's stickers, grab them. If anybody wants to talk about this, please reach out to me. Like, if anybody wants to work on like a modular testing subsystem for Salt, like, let's do it, you know? I'm into this. Yeah, I think that's all I got. Oh, one more thing. So since I did really mean for this to be a live demo, and I have like this whole chunk of code that does, you know, the other thing I had driven up here, but it just isn't working, so it feels pointless to do a demo of it. I will get it fixed. I'll try to do it this weekend and get it on my GitHub repo. So that's my condolence prize for you. It's cool. Thank you, guys.